And I always will. Yes. And I always will. But for me, I'm just beginning. And my emergence is only the start.
They just keep growing bigger and more powerful. Mom thought the Alliance would save us. But every time our side got stronger, so did they. Back and forth. War only brought more.
My style is ridiculous.
Yes, yes. first build a magnetic shield to protect the planet from the solar wind. We would then release chlorofluorocarbons into the atmosphere, causing a greenhouse effect that would melt Mars' polar ice. We would then heat up Mars' regolith, releasing CO2 into the atmosphere. To thicken it more, we would then import more CO2 from other planets, and also divert ammonia-rich comets to collide with Mars, releasing nitrogen and hydrogen. Finally, we would release plants, making Mars green and converting CO2 into oxygen to establish a breathable atmosphere for humans. To terraform Mars, we into an Earth-like paradise. Billions of years ago, Mars had a magnetic field and an atmosphere of similar density to Earth's today. Its temperature was above freezing, and it contained massive amounts of surface water, which formed an ocean covering the planet's northern hemisphere. There was a climate and maybe even life. However, around 4 billion years ago, the convection in Mars' iron core, which generated its magnetic field, shut down. With no magnetic field deflecting charged particles, Mars' atmosphere was all of a sudden exposed to the solar wind. Over the next several billion years, solar wind particles slowly stripped Mars' atmosphere. With no insulation, magnetic field, there is a solar wind particle over millions would be Mars lived but extremely powerful greenhouse gases such as chlorofluorocarbons. This would lead to a temporary greenhouse effect. The heating from this would turn some of the polar ice caps into gas. This gas would add to the greenhouse effect, raising temperatures and causing more ice to become gas. Eventually, all of the ice would turn into atmosphere, doubling the planet's atmospheric pressure. This process would require around 39 million tons of chlorofluorocarbons, 3 times the amount produced on Earth between 1972 and 1992. This amount could be produced on Mars in nuclear-powered factories with local materials. In addition to vaporizing ice caps, if Mars' regolith was heated, the CO2 attached to it would eventually be released. This would add about 0.04 bars of pressure, a major increase. Lastly, shallow carbon-bearing minerals and ice clathrates could be mined and heated, releasing another 0.017 bars of pressure. With all these methods, Mars' atmosphere could be heated enough to allow for the presence of liquid water. There would be weather and a global ocean covering the northern hemisphere. Still though, Mars would be far from habitable. All this would increase the pressure to only 6.9% of Earth's. To raise this level, it's been hypothesized that carbon-bearing minerals deep in the crust could be mined and heated. This could raise pressure levels up to 1 bar. However, currently, the quantity of these minerals is unknown, and this process would be incredibly difficult. Another solution is diverting ammonia-rich comets in the outer solar system to collide with Mars. This ammonia would quickly break down into hydrogen and nitrogen, thickening the atmosphere. Lastly, we could import hydrocarbons or carbon dioxide from Earth, Venus, or Saturn's moon Titan. These combined sources could get Mars' atmosphere, thickening the atmosphere. Lastly, we could import hydrocarbons or carbon dioxide from Earth, Venus, or Saturn's moon Titan. These combined sources could get Mars' atmosphere up to 1 bar. People would be able to walk on Mars' surface with no pressure suit and would only need a mask providing breathable air. But this is not enough. We want a breathable atmosphere. At this point, Mars' atmosphere would be primarily carbon dioxide. However, for humans, breathing any atmosphere over 1% carbon dioxide would cause drowsiness, and anything over 10% would likely mean death. To reduce the concentration of carbon dioxide while increasing oxygen, Mars will go green. Right now, Martian soil has about a 0.5% concentration of perchlorate, which is toxic to humans. In fact, it will provide a major health threat for early astronauts. However, some bacteria naturally consume perchlorate. These bacteria, combined with filtering systems, can eliminate the toxic chemical. Meanwhile, we can release microbes and mosses around the planet. These will spread, making healthy soil while turning carbon dioxide into oxygen. During this time, ozone will also be mass-produced to establish an artificial ozone layer. Slowly, larger plants will be incorporated into the environment. Fertilizer will help lighten and enrich the soil. However, due to the relatively low light levels on Mars, only certain plants will be able to survive. Gradually, Martian forests, grasslands, coral reefs, and other habitats will develop. Farmland will be established, growing food for humanity's expanding interplanetary population. And finally, after adjusting it to perfection, the Martian atmosphere will be breathable. Over millions of years, due to Mars' small size and therefore minimal escape velocity, some of this atmosphere will slowly escape. However, occasional resource imports will manage this. With everything in place, animals will be released into the wild, and millions will emigrate to the planet. Still though, life on terraformed Mars would be very different from Earth. The gravity would be only 38% of Earth's, which local populations would have to adjust to. In addition, each Martian day would be 24 hours and 37 minutes long, and each year would be 687 days long. Also, there would be a lot less light than Earth, and with no major moon, there would be no tides. Since Mars has a similar tilt to Earth, there would still be seasons. However, because Mars has a much more elliptical orbit around the Sun, these seasons would be much more erratic. With no mountain chains and almost all the water in one hemisphere, the planet's climate would be very different from Earth's. Furthermore, a lack of plate tectonics would mean no recycling of carbon, water, or land over millions of years. On the positive side though, there would be no earthquakes, volcanoes, or tsunamis. However, there would likely still be huge dust storms. Lastly, the livable area would be much smaller than Earth's. Mars has only 28% of Earth's surface area. In review, terraforming Mars is certainly possible. However, it would take hundreds or even thousands